Okay, we are talking about slope-intercept form of a linear equation today. And this page has so much going on that what I'm going to do is I'm going to cover up everything except the one bit that I want to talk about right now. And let me just say this, okay? There is just a whole group of functions that are based on the most basic function called the parent function, and this is what we're going to say it is. It's y equals x. And if you know anything about the invisible coefficient of x, there's a 1 here, okay? Right? So y equals x is the same as saying y equals 1x, and it's also the same as saying plus we don't have anything added onto it, okay? So you can imagine that there's an invisible coefficient of 1, which always is true when you have a variable with no visible coefficient, then it's always assumed to be 1. And adding 0 to something doesn't change it. That matters because what we're eventually going to be doing is writing an equation in the form of y equals mx plus b. And what you can see here is that in this case, m is 1 and b is 0. Okay? But for now, let's say I want to talk about the parent function of y equals x. Okay, y equals x looks like this. Let me draw a line here and adjust it. Okay, y equals x basically says the y coordinate is equal to the x coordinate. So if we said that the y coordinate was 2, I'm sorry, the x coordinate was 2, then the y coordinate would be 2 as well. Okay, the y and the x are equal. And where do we see that? Well, we see that right here at 2, 2, right there. That's this point right here, 2, 2. 2, 2 is on our line. And the same thing for any other point. If we had the y coordinate equaling the x coordinate, we could say, okay, that would be then maybe -5, -5, where the x coordinate and the y coordinate are the same number. Okay, where do we see that? -5, -5, that's right down there. That point is also on the line. Okay, this is the parent function. This is the most basic type of this equation. And then what we can do up here is we can say, we can actually modify it by changing what we add on to the end, let's say +1, or we're changing the coefficient of x in order to make it -1/2 instead of just a +1. And the line will tilt and shift, but it's still a straight line. That's the idea of linear functions, okay, y equals x. Now, the second part of the screen just says that a linear equation is one that models a linear function, meaning a line. You can see this orange straight line. That is what a line is. It's straight. These are curves. This one in red curves like that. This one in purple curves like that. And I'll talk about those in a second, okay? In a linear function, the variables cannot be raised to a power other than 1. So this is a linear function, and that's in orange, y equals 2x. I've done that in Desmos, and you see that it forms a line, okay? But y equals x squared, which is in red, that's actually a parabolic curve, not a straight line. And y equals 2 raised to the x power, where that's the thing that changes, the exponent, and that looks like this, where it starts small and then it rises really greatly, exponential. Okay, they are not linear. They do not form straight lines. Yep. And then, of course, the graph of a linear equation. This graph is all of those different locations, the x and y values of each point all along there are all of the solutions to the equation. Now, what this section suggests is just that the lines, the graphs of the linear functions, they can cross the y-axis, this vertical axis, at any point, okay? This parent function, it crosses it at 0, but this one actually crosses down here at -3. Where does it hit that y-axis, okay? We call that the Y-intercept, and we're gonna need that. So that's just basically what it's saying, is that when you draw the line, where does it cross this vertical y-axis? We'll call that the Y-intercept, okay? And we can use the slope and the Y-intercept of a line to write the equation, and we can also use that information to graph it. Okay, so actually this bottom bit here says slope-intercept form is written like this, where we say y equals mx plus b, where m is the slope or how the line is tilted, and b is the number for where it crosses the y-axis. Yep, that's the big idea. Okay, so this first part is pretty basic. And it says, what are the slope and y-intercept of the graph of this equation, y equals 5x minus 2? Well, as we can see straight away, we know that right here is what's going to be the slope, and right here is going to be the y-intercept, because that's how those equations are written. So, right there, slope is 5, y-intercept is negative 2. Okay? You're going to do this problem right here. What are the slope and the y-intercept of this equation? And how do the graph of the line and the equation change if the y-intercept is moved down 3 units? Try both of those and see what you come up with. Okay, so what is the slope? The slope is the coefficient of x when it's written in this form. So the slope, or m, is equal to negative 1/2. You never write x on the slope. It's not negative 1/2 x. The x is separate from the slope. Okay, and what is the y-intercept, otherwise known as b? And that is that value right there, 2/3. So that's the answer for A. Now B, what are the graph of the line and the equation? How do they change if the y-intercept is moved down 3 units? Well, if you go down 3 units, then the y-intercept is going to go from -2 to -5, okay? So the answer would be, how would the graph of the line change? I would say the line would be shifted down 3 units. And by the way, the slope would stay the same. Three units. Okay. And how would the equation change? Well, the equation would change from the y-intercept being -2 to the y-intercept being -5. So it would be then y equals 5x minus 5. Okay. And that's modifying that equation by shifting it down 3. Okay. There you go. So let's write some equations in slope-intercept form. What is an equation of a line with a slope of -4/5 and a y-intercept of 7? Well, we're using this formula, y equals mx plus b, where m is the slope. They're telling us that that's the slope, so you replace m with that number. And this is the y-intercept. We replace b with that number. So the equation then is y equals -4/5 x plus 7. Okay, and when can we use this? When we know the slope and the y-intercept and it's not vertical, because remember, perfectly vertical lines we say have an undefined slope, and that's not a number, so we couldn't replace m with the word undefined. It doesn't make sense. So as long as it's not a perfectly vertical line, which there is a way to write an equation for that, but we'll learn that later, you just replace the slope where m goes and the y-intercept where b is. Okay, so what would be the equation for the line that had this slope 3/2 and this y-intercept -1/2? Give it a try. Okay, so what do? We take the formula y equals mx plus b, and remember m is the slope and b is the y-intercept, where it crosses the y-axis. So we replace those, and if we did that, we would then say y equals, what is m? What is the slope? They say it's 3/2. So y equals 3/2 x, and that y-intercept is -1. We don't put plus a -1. We just say -1. That's the equation. Very straightforward. Now what they're asking here is, which of the four equations given as a multiple choice question match the graph shown? So what does the graph tell us about the slope? Well, we know that it rises as you go to the right, right? It slants up. So the slope of the line should be positive. So any equation that doesn't have it as positive, like A, it's not going to be that one, right? And by the way, as you get steeper, as this number for the slope gets greater than 1, the line is going to tilt more steeply. And so we should have a slope that's greater than 1, okay? But the very first thing that we can do is we can say, okay, as they just pointed out, we know that the slope is positive, so we're already going to eliminate this one as a choice, okay? Now, let's eliminate some more. What's another way of doing it? Well, we can say, where does it cross the y-axis? Well, it crosses the y-axis at -1, -2. So we know we have to have a y-intercept of -2. And B does not have a y-intercept of -2. It's got it at +1, but it's not crossing here at +1, so it couldn't be that one, so we can eliminate that. Now, as they suggested down here, the line is fairly steep, so it should be greater than 1. That's suggesting that the answer is D, okay? But we can actually take any 2 points, for example, that this point right here and this point right here that perfectly cross the grid lines of the graph paper, and you can say, how much do you rise and run to get from one to the other? Well, you rise 2, run 1. Rise 2, run 1. Rise over run, 2 over 1. 2 over 1 is equal to 2, and that means we should have a slope of 2. And so yes, that's right, we should have D as our answer, okay? And if we looked at the way that they explain it to us, because this is an example problem, let's see what they tell us. Okay, they say you can actually find the slope by calculating by doing y2 minus y1 over x2 minus x1. Since we have it graphically, we can just say, we can actually look at it and just say rise of 2. I'll make that a little bigger. Rise of 2, run of 1, 2 over 1. And that's what they get for a slope of 2 there, okay? Now we need to write it. The y-intercept is -2, so that's down here. And so we should have -2 for the y-intercept, and we should have 2 for the slope, which we just calculated as 2 over 1. And so it's y equals 2x minus 2. Yep. Excuse me. Try this got it problem. What do you expect the slope of the line to be from looking at the graph? Just what features do you think it should be? Excuse me. And what is the equation of the line shown here? Okay. Now, does the equation of the line depend on the points you use to find the slope? Answer those questions and we'll come back in a second to provide the solution. All right, so what do we expect the slope of the line to be? Well, we certainly expect it to be negative, right? But if you drop 1 and run 1, -1 over 1 means a -1 slope. So it should be negative, and very specifically, it should be -1. So I'm going to actually write it as m equals -1. And what is an equation? Well, where is it crossing the y-axis? It's crossing at 2. So if we did y equals mx plus b, we know that the slope is -1, so we can say y equals -1 x and it crosses the y-axis at +2, so we can say it's got a b value or a y-intercept of 2. Now, we never write it like this. We never write -1x. We just write -x. So I'm going to actually get that out of there, and that then is our answer. When you have -x, it implies -1x. And does the equation of the line depend on the points that you use to find the slope? Never. Any 2 points on the line, since it's straight, will give you the same slope. So does the equation of the line depend on the points you use? Nope. Any 2 points will always give you the same slope. Okay, now this is where it gets a little bit more challenging in that you're given 2 points and it says what's the equation in slope-intercept form. So this is what you'll need to do here. You'll need to first find the slope. And by the way, this says, what do we know? We know that the line passes through those 2 points. And what do we need? Well, we need an equation for the line because that's what it's asking for. It says what equation? So what's the plan? The plan, we can use the 2 points to find the slope, and then we can use the slope and one of the points in the equation to find the b value, the y-intercept, okay, which is something that you haven't seen before, and we're about to do it now. Okay, so can you use either point to find the y-intercept? Yes. How are we going to do it? Check it out. First thing that we're going to do is we're going to say use the 2 points, and we're going to find the slope. y2 minus y1 over x2 minus x1, right? So if I label them, and I probably should for your sake for now, this is x1, y1, this is x2, y2, and so y2 is right there, minus y1 over x2, which is right there, minus x1. When we calculate this out, we get a -3 slope. So we can put that in there. Now, we also notice that this equation has 4 variables, y, m, x, and b. If we want to find out what b is, we can say we can use one of the x and y values, 2, 1, that we know. So we can say we know that 2 is one of the values that will work, and the matching y value is 1. We know that the slope is -3. And then what must come out for b in order to make this true? If you were to calculate it all out and solve it, you would find out that b is equal to 7. And that means that we can have an equation of y equals -3x plus 7. That's this right here. Okay? And the way that we did that is we calculated the slope first, and then we replaced the slope and one x and y value from one of the points we know to find out what b is. Okay, you're going to have to do the same thing here for this one, where you're going to have to find the slope and then substitute one of the points and that slope into the equation to solve for b. Give it a try. All right, so here's the solution of this. I marked the points here, and actually maybe I just section it off a little bit better so that you can see. Oops. What I've done there is I've marked these points as that's point number 1, so that's the x coordinate of point 1 and the y coordinate of point 1. And this is point 2, so that's the x coordinate of point 2 and the y coordinate of point 2. Now, to find the slope, we always do y2 minus y1 over x2 minus x1. And now I just plugged in those numbers, y2 minus y1 over x2 minus x1. And what do we get here? Well, as it turns out, subtracting a -2 is the same as adding 2. So -3 plus 2 is -1. And down here, 1 minus 3 is -2. Okay, so these two negatives cancel out, and we get a slope of 1/2. Now we take this formula, y equals mx plus b, and we put in 1/2 for the slope, which we just found. And then we take one of the points, I picked this one, and we put the x coordinate where x is, and the y coordinate where y is, and then solve it out. This is -3. This 1/2 of 1 is 1/2, and subtracting that from both sides to get b by itself gives you -3 and 1/2 for the b value. So now you can write the final equation as y equals the slope we found, 1/2 x, minus then the b value that we found, 3.5. And that is our equation. Okay, we're now leaving off on something that's a little bit easier than what that last bit was, which is just how do we graph this? What's the graph of y equals 2x minus 1, okay? And basically, if we're gonna have the slope of 2, which is really, if you ever have a whole number, you put it over 1 so that you have a rise and a run. That's like 2 over 1. Okay, so that would mean you would rise 2 and run 1. But from where? Well, we need to start with a point we know is on the line, and we know that our line crosses the y-axis at -1 because of this. So we can start at -1 on the y-axis and then rise 2 and run 1 from there, and get a second point and just connect them. That's what this looks like, okay? They say the y-intercept is -1, so plot a point there at 0, -1, which is that. And then from there, the slope is 2 or 2 over 1. So move up 2 units to the right one, plot that second point, and now you can just connect them. Okay? You're going to do that with these two. You're going to try and graph them, and we will come back in a second and compare it to yours. What you need to do here is have a graph paper, have a piece of graph paper. If you don't hand draw your graphs. Make yourself go out and buy some graph paper so that you have this for these, because we're going to need these for the rest of the semester. So you need graph paper. Okay. How do we graph this? Let's take a look at it. Try it first, and then we'll come back. All right. So what do we need to do for this first one? Well, the y-intercept is 4. So the first thing that we need to do is we need to put a point here at 4 right on the y-axis. Okay. And then from there, the slope is -3 or -3 over 1. So that means we drop 3 and run 1 right there. Right? And then we need to connect those points. And so I'm going to take my line maker and connect those points like that. And I can adjust them a little bit to make it properly go through the points. Yep. And that's what your line will look like for that one. How about the second one? We're going to do the same thing. We're going to say, okay, we need to put a point down here at -8 on the y-axis. It's always the y-axis. And then the slope is 4 or 4 over 1. So we're going to rise 4, run 1, and that's this point right there. And now I will use my line making tool to make a line that runs through them, and I'll have to adjust that properly so that it runs through them both. And that's what your graph would look like. Yep. Okay, so as I said before, my access to the teacher textbook is unavailable now, so I don't have a screenshot of these solutions really easily, but I'll get them and I'll embed them later. So you might not do these lesson check problems, but you certainly have homework to do, and you can give it a go and ask me any questions that you have. Good luck.